Hey everyone, my name is Kingsley, and today I'll be explaining the centroids of plane regions. Alright, let's go over the formulas for x bar and y bar first. It says here that the x bar formula is 1 over the area times the integral from a to b of x times f of x dx. And so how did we get that? Well, we are imagining this function here as the combination of a bunch of Riemann sums, so that explains the integral part that goes from a to b, and the x here is the distance of the centroid from the y-axis, and the f of x would be the mass of one of our Riemann rectangles. And so we are multiplying the distance and the mass, and then we're dividing it by the area of this whole section. And so that gets us the x position of our centroid. But it's different for y because we're not finding the distance of the centroid from the y-axis, we're finding the distance of the centroid from the x-axis. And that would be 1/2 of just 1/2 of y. And since y is equal to f of x in this case, it would just be, since we're also multiplying it by f of x, since that's the mass, it would just be 1/2 f of x squared dx. But it's different for when you're trying to find the centroid in between two functions. Let's say that f of x is on top and g of x is on the bottom, and that f of x is greater than or equal to g of x. So for the x bar equation, it's pretty simple. You just plug in the minus g of x and then multiply that by x. So it would just be 1 over the area times the integral from a to b of x times f of x minus gx dx. But for y, it's a little bit different. Since the centroid is in between these two functions, you need to take the centroid position as f of x minus g of x, which would be this part here, and then f of x plus g of x, which would be at the top here. And then you need to multiply those together, which would get you f of x squared minus g of x squared, which is what we have in our integral here. And again, since we're trying to find the distance of the centroid from the x-axis, we have to put this 1/2 in here. So the example problem I chose to illustrate this is example 6, and it says, find the centroid of the region bounded by the line y equals x and the parabola y equals x squared. And so when you draw it out, you see that that it intersects at 0 and at 1, 1. And for that period, y equals x is bigger than y equals x squared. And so for that reason, f of x is x, and then our g of x is going to be x squared. And since it goes from 0 to 1, a is 0 and b equals 1. And first we have to find the area of the section under the curve, or in between these two curves. And we do that by doing the integral from 0 to 1 of x minus x squared dx. And then that integral comes out to x squared over 2 minus x cubed over 3. And then we plug in 0 and 1, and then that comes out to 1 over 6. So our area in between these two curves is 1 over 6. And now that we have everything, let's plug it into our x bar and y bar equations, where our x bar equation will be 1 over 1/6 times the integral from 0 to 1 of x times x minus x squared dx. And what we can do here to simplify it is distribute the x inside the parentheses, and then we can simplify this fraction by just making it 6. So our simplified integral is 6 times the integral from 0 to 1 of x squared minus x cubed dx. And when you integrate x squared minus x cubed, you get x cubed over 3 minus x to the 4th over 4. Plug in 1 and 0 for that, and then that equals 1/2. And so that will be the x position of our centroid is 1/2. And then let's do our y bar, which is equal to 1 over 1/6 times the integral from 0 to 1 of 1/2 times, this would be x squared minus x squared squared, and that x squared is x squared, and x squared squared is x to the fourth. Since whenever you square something with exponent, you just multiply the exponents. And then that equals out to 6, as we've seen here, since 1 over 1/6 is equal to 6. And what we can also do here to simplify it further is bring out the 1/2. And so we get 6 times 1/2 times the integral from 0 to 1 of x squared minus x to the fourth dx. And since 6 times 1/2 is 3, and then the integral of x squared minus x to the fourth is x cubed over 3 minus x to the fifth over 5. We plug in 0 and 1 for that, and then we get our y value of our centroid is 2 over 5. And so the position of the centroid would be at x equals 1/2 and x equals 2 over 5, which we can see here.